So here we're looking at section 7.6, and now let's talk about density and mass. So this is kind of a unit thing, sort of a physics thing, and let's just talk areas. And it could also be a length, something like that. So, a density is some number per unit length, area, something like that. So what you often see are things like, population per square mile. Okay, so you've got a population per square mile. Other things that really act like densities, I have over the years bought lots of things like cable and chain and rope and so forth for various household tasks. Fence, that's another one, buying fence. And those are usually in something like dollars per foot. Okay, so again, there's our measure that we're interested in, that is some number, and then it's per some kind of measurement length. Or width, or what's length or width, length or area or something, or volume. So, we could have things per square unit or per unit. And so generally what we're going to do is designate density with this rho, and rho is in a number per unit, number per square unit, or number per, and we could have said, instead of square unit, unit squared. How about unit cubed? Something like that. And you could actually keep going up in dimension, but why would you want to? So this density, and then if this number is a mass, then we can get our total mass is equal to our density, and then times either a length from our first case up there. It could be rho times an area, if those are the units, per square unit or per unit squared, or rho times a volume. Okay, and we can get our total mass if our density is in terms of mass per unit length, or mass per unit squared, or mass per unit cubed, something like that. So that's how we can get a total mass from an area and a density. Now I'm going to start with length, and so you could have an example of a chain has, I was going to say weighs, but really you should talk mass, so has a density of say, as soon as you go into mass, I like using metric units, because you don't have to worry about all those weird things like slugs and and so forth. So maybe it's it's a pretty small chain, lightweight chain, something like that, and so maybe it's just like 200 grams per meter. Okay, then 5 meters of chain has has mass of 5 meters times 200 grams per meter. Meters disappears, and we get 1,000 grams or 1 kilogram. Okay, so similarly, I could pick up some medium density fiberboard, MDF, and MDF has a density. Now, I'm not sure exactly how you put, if these are real units, like a hernia per square foot or something like that. But MDF is pretty heavy stuff. I'm not sure exactly what it would be, but gosh, give me a second and I'll kind of come up with a guess anyway. So say per square meter, it might weigh, I don't know, 15 kilograms. So that's what we'll go with. 15 kilograms. It's probably not that heavy. Maybe 10 kilograms per meter squared. And so I go and buy, a 4x8 sheet. That's 32 square feet, which in yards, I divide by 9. I'm going to divide by 10 to make it square meters, about somewhere in there. And so, I buy a 4x8 sheet, which is maybe 3.2 meters squared, times that 15 kilograms per meter squared. That cancels, and I get 48 kilograms. Yes, that's too heavy, because that's like over 100 pounds. It's not that heavy. But hey, don't wreck a good story with facts. Okay, so that's how we use density and areas or length. Again, I could do something with volume, but we don't really do much with volume yet, and other than maybe a solid of revolution, and with that, if I did a solid of revolution, well, there's a lot of symmetry in that, so I wouldn't have to worry. It wouldn't be so hard to come up with centers of mass in much of it. All right, so there we have mass and density, and so now I think we're ready to do some calculus.